Alrighty, here we go. Section 3, solving quadratic equations. You're going to use this to actually find the solutions. You're going to either do it with graphing or by using square roots. You can look at this, but what we want to realize is here's the parabola. You see how it crosses the x-axis twice? Those are the solutions. They're called the x-intercepts, they're called the roots, they're called the zeros of the function. Okay? So we are looking for the location where the graph crosses the x-axis in this section. We've done it in chapter number 8, where we've factored. So this one is going to be kind of building upon that idea. Okay, so let's look at a few problems. Here is the graph of x squared minus 1 equals 0. You will notice that it crosses the x-axis at these 2 points, so the solution is that there are 2, and it's positive 1 and negative 1. Another type of graph is this one, x squared equals 0. You'll notice that it only touches the x-axis once. The answer is the solution of 0. There's only 1. Then we have a third type, x squared plus 1 equals 0. Look at the graph. It never crosses the x-axis, so therefore there is no solution. Okay. You will notice that we have 3 different types. We have one with a subtraction, we have one without a c value, and we have one with addition. You will notice how it's pretty much the same graph, it's just being shifted down 1, right in the center, up 1. Okay? So there are 3 here. I would like for you to practice those on your own. Okay, we can solve the equations of this form, x squared equals k, by finding the square roots of each side. For example, the solution of x squared equals 81 are the positive and negative square root of 81, which is positive and negative 9. Okay, so what we have here is we need to solve it for the x, then we divide everything by 3. We get x squared equals 25, so x is equal to the positive and negative square root of 25, so x equals positive and negative 5. That would be your solution. Okay, we do this whenever we have a perfect square. We can do it without perfect squares as well. So it is a technique that will work no matter what, especially since you're using little eagle demon boxes. Right? Here are 2 for you to practice. You'll probably notice that this one is going to be a little weird. Okay? Just mark my words. Check it out. All right. Reasonable solution. An aquarium is designing a new exhibit to showcase tropical fish. You'll notice that the exhibit looks like this. The exhibit will include a tank that is a rectangular prism with a length L that is twice the width W. The volume of the tank is 420 feet cubed. What is the width of the tank to the nearest 1/10 of a foot? Okay, so the height is 3. The length is going to be twice the width. Okay, so we have the formula, volume is equal to length times width times height. The volume is 420. The height is 3. The length is equal to 2 times the width, so we will replace the L with 2W. So we have 2W times W times 3, so that's 6W squared. Divide both sides by 6. We get W squared equals 70. W is then the positive and negative square root of 70, which means there are 2 answers. Either the answer is going to be 8.4 feet or negative 8.4 feet. Remember, it said choosing a reasonable solution. It doesn't make sense to have a negative width. So the final answer would be 8.4. So we use the fact that we know the volume of a rectangular prism, length times width times height. We use the fact that the length is 3, the width is W, and the length is the same thing as 2 times W. And then we go through the process of solving it. Okay? Suppose the tank in problem 3 will have a height of 4 and a volume of 500. So now we're changing some of the numbers. We're taking out the 3 that was in the original problem. We're putting in a 4. We're changing out the 420. We're putting in a 500. They're looking for the width of the tank to the nearest tenth of a foot. I'm going to let you work on that question. If you need to, pause this, rewind it a little bit so you can look at the formula, at least the information, if you didn't deal with it when it was on that slide with the picture of the tank. You can change the numbers, you can do whatever you need to do to help you figure it out, okay? And that's the section. So I'm going to leave you with a few practice problems. You can either graph these, or you can find the square roots of them as well. Right? I would suggest that you graph at least one. Just so you can visualize how it works, okay? The process of graphing it and whatnot. Granted, you can solve each of these by finding square roots. But please try and at least graph one. You're probably not going to choose that as often as you get the chance, so I want you to take a chance to do it right now, okay? That is section number 3, and I hope it makes sense. See ya.